The graph of y equals f is given below. So we got a graph. Find the intervals where f prime is bigger than 0, first derivative positive, first derivative negative, second derivative positive, and second derivative negative. Okay, looking from this graph, we know that when a function is increasing, then we get first derivative positive. When the function is decreasing, that means derivative is negative. And where the graph is concave upward, like this shape, concave upward, second derivative is positive. And when the graph is concave downward, like this shape, second derivative is negative. So let's answer this. So increasing, so we need to read from left to right, okay? And it's going forever here, it's increasing forever. Reading from left means negative infinity, and this is positive infinity on x. So this part is going up, increasing up to 0. That means all the way from 0. So f prime is positive. That means where the function is increasing at or on, here to here, negative infinity all the way to 0. And now then from 0 to here up to 2, okay, it's increasing. That means first derivative positive. On this portion is decreasing. Okay, and we got a relative minimum here, by the way. 0 to 1 decreasing, that means, 0 to 2 decreasing, means first derivative is negative. Again, from 2 to all the way, the graph is going up again. So f prime is positive there. Negative infinity through 0 and where? 2 to infinity. And f prime is negative where the graph is decreasing. We saw from 0 to 2. Now we need to see where it's concave up and concave down. So let me erase these marks. So concave up, let me try to trace concave up and down. So we need to go from left to right always. So it's going increasing, now decreasing, maybe somewhere it's concave downward. So all the way to, let's say, up to 1. Here it's concave downward. That means second derivative negative. From here 1 all the way, that's positive infinity, all the way it's concave upward. That means second derivative is positive. So here second derivative is negative. So let me write that. Second derivative is positive on concave upward on here, 1 through all the way, 1 through infinity. Second derivative is less than 0, concave downward, all the way through 1. Okay, in part B, we are asked to find relative maximum minimum. Okay, relative maximum minimums are related to first derivative, by the way. And we can clearly see some points like here. Okay, it was going up, then it starts down. So this is relative maximum. Okay, and now decreasing. So this is relative minimum. So minimum occurs at -2, and the minimum value is -4. Okay, the graph is here -4. So let's write that. Relative max here at 0, and the value is also 0. 0, 0. This is the location, and this is the relative maximum value. Relative minimum. Location is at 2, and the value is, this is -4. Okay. In part C, we are asked to find the inflection points. Okay, inflection points. That means where the concavity changes. We saw last time, this is concave downward up to here 1, then after that is concave upward. So concavity changes here, that 1, -2. And that's the only inflection point we have. See, inflection point means always x and y coordinates. So at 1, so this point means 1, -2. Final.